Hi, welcome back. I couldn't wait. I had to solve this. I had to find the bug, but I also had to revisit what I learned because I know the series name is Learning C every other day, but sometimes I could have like a couple of days of break and I completely forget the topic of the conversation. So what I will do, I will just reiterate what I've learned about functions in C, but at the same time I'll see, following the book, whether is there something I missed. So let's do this. First of all, what's a functions? Functions are the essence of all the programming. Functions are nothing more like bits of reusable code. I think that's the most important thing. Bits of reusable code. And that's it. For someone who's just starting programming, now that sounds like a lot of gibberish, but for someone who at least knows the basics, you know it's, if this is your code, you know that you can use this guy and just plug it in anywhere. It's the most abstract way possible. Okay. So there's an interesting point in the book in which every new innovation in programming or technique changes the basic programming paradigm. And all of these are somewhat referred as different abstractions. And every different way of thinking is just another way to learn new information about something. Because in the end, if we have something like this and we take a part of it away, like this part, we still need to think about this part and the whole, but also the way how the part fits in the whole. So yeah. So functions, in essence, are a way of abstracting the logics and the detail. And we can think of them as computations that we want to perform at a later time. Basically meaning, if I have something called foo, I know that I will plug it in here, or that it's this piece of the pie here. It's foo. I want to reuse it later. And I want to use this name when I want whatever foo is doing, when I want whatever it is to happen. So most functions should be defined once. Most functions should be reused. So, okay. Another way to think of functions is like a black box that takes an input and produces an output. Yeah, true. Why is this important? Why is this definition of a function important? Because we do not care what happens inside. I don't care. This could be a complex and tedious process, but I don't care because I only care what I provide to the function and what the function gives me back. And also, interesting, all of these are functional, all of these are ideas about functions. So, what is being said here in the book? We are going to create all of these ideas to add user-defined functions to our language. So, first things first, we need to create user-defined functions. first thing is to do this. So what will we have? We will have arguments in the function. That will be our list of symbols or formal arguments. They are our inputs, x and epsilon, let's say. And the second argument is another list of arguments. Sorry, this is not supposed to be here. No, I thought that was the remove. This is the remove. Yeah, this is not supposed to be here. And the second argument is another list of arguments, and we will evaluate this guy. Okay, now the second time around, I understand a lot more than I did the first time. And the book says to create a function which takes two inputs and adds them together, we would write something like this. Oops, something like this. Actually, I already wrote it. I don't need it anymore, but this symbol or the lambda symbol will be the delimiter, which will say, okay, this is a function from now on. And this, my friends, doesn't work in our implementation. Bum. This won't work. I'm 100% sure this won't work. It works. Is this working? So it's the same thing, but only this time I'll provide some arguments. And I'm gonna close this. Okay, now I have the segmentation fault. Okay. So what I did here is I called the function by writing it here and setting the arguments. I could also define the function by, I need to run this again, doing this. But this also won't work. This also doesn't work. So, doesn't matter. Let's do this. Let's go. Let's do this. Store a function, we need to think exactly what it consists of. So what should a function consist of? A list of formal arguments. Function parts. List of formal arguments. So what are they? What is the list of formal arguments? They also have a coup expression or the body, and what is the third part? An environment to store the values assigned to the formal arguments. Okay. Okay. So what was done here in the book? We created a type, LOL fun. And the thing is, now we have built-in methods and we have user-defined methods. So we need a way to distinguish between them. And this is the type. This is the type. struct lval. Let me just check the type one more time. It's here. So this is the type that we had, and this is the Lisp value in our structure in our application, and it consists of all the different types of Lisp values, which are just manipulated tokens from the grammar that we created. Okay. So I have a struct lval. I have a type. I have, okay, I just realized this should be here and this should be here. Oops, here. And this is the function related data. We have the built-in, we have the environment, we have the formals, and we have the body of it. Everything else, I don't need. Built-in. Let me just check something before we continue. Built-in fun. Okay, let's go back. So this is the structure one more time. Okay. Okay, this is okay. Next thing next. What we created is this. It's a constructor for user-defined functions, which is this method. It checks the size of Lisp value. It assigns the type lval, the type function. I create a new environment. I have the formals. I have the body. Okay. So I'm just checking. Yeah, I'm just checking the cases in our manipulation functions to see what's happening here. So this should be okay. If there is no built-in method, so if there is no built-in method, if it's a user-defined method, I'm deleting the environment, I'm deleting the formals, and I'm deleting the body. Okay. Next is the print. If this is built-in, I'm printing built-in. Otherwise, I'm printing this and all of these information. Okay. And I should have another one of these. Yeah. Copying. If it's a built-in. So if it's a built-in method, if it is a built-in method, what's up? Well, let me open another one of these. So if it is a built-in method, I'm setting it. Okay, otherwise I'm setting the built-in to null. I'm copying the environment. I'm copying the formals. And I'm copying the body. I think the issue could also stem from some of these copy methods. They might be wrong. But let me continue with the functions. Now the lambda function. It's a built-in for a lambda function. Built-in lambda. It's this guy. It's this guy. I don't think this is fixing it, but there's no way this is fixing it. It's just an assertion. Yeah, it's just an assertion. So this is a lambda function. What are we taking as inputs? A list of symbols and a list that represents the code. And it should return a function elbow. Okay, we do some error checking and we pop the first few arguments and pass them to. Okay, so what is this? Where's my pen? Okay, here is where the fun starts. Built-in lambda environment and the Lisp value A. So what it does some assertions. And then we are checking whether the first lambda function creates a lambda type. So what are we doing here? We are iterating through the cells, checking the count. Then we assert the type. All of the types should be symbols. Yeah, okay. I'm taking the formals and I'm taking the body and I'm deleting. Oh no, what have I done? And I'm deleting the Lisp value. Okay. What have I done? What's this? I don't want it visually. Lenv. Wait, let me. Yeah. Okay, so this adds built-ins, and this is my lambda built-in, which works, right? It works. Yeah, this one works. Let me just check something. This works. This creates a. Oh, okay. So the lambdas are working. The def is not working. So let me just switch to built-in lambda again. This is the method. It should be okay. So what should do now is what so we have given functions their own environment. Create a new environment for functions. Okay, new environment for functions. But functions should also be able to access variables which are the global context. Should also access global context. Okay. So how can we implement this? Here it says, change the definition of our environment to contain a reference to some parent environment. Parent environment. Parent environment. I think I'm on a track. So when we want to evaluate a function, we can set this parent environment to a global environment. So what we will do here is check our Lisp environment structure. So it will be a reference to the parent environment. When we add this to our Lisp environment struct, it will be a reference to a parent environment. Not some sub-environment. Because of this, we shouldn't delete it when our len gets deleted or copy it when our len gets copied. But this is contextually simple. If we have a couple of my hand is very shaky. So if I have a couple of environments here and I'm searching for A and I know that A is here, if there's no A in the smallest one, it should go to the bigger one and then it should go to the bigger one and find A. It's conceptually very simple. So if the symbol cannot be found, it will look in the parent environment to see if the value exists there and repeat the process until it finds it. So this should be okay. I have the parent, I have the count, I have the symbols, I have the values. Let me just check how I create the Lisp environment again. Count 0. Sims null, false null, parents null. Okay. How can we get values from the environment? Okay. So what's happening here? I have an environment count. So I'm iterating through the environment. So I'm going through the environment. I'm looking at the symbol, comparing it with the symbol if it's there. I'm copying it. If it's apparent, I'm just doing this again. I'm running a recursion. Otherwise, there's no symbol. So why do we have this method here? Because we have a new Lisp value type that has its own environment. And this is the function. This is the function, right? We need a function for copying environments to use when we copy Elval struct. Ah, yeah, because sometimes I would like to make a copy of a structure. So I also need environments that come with it. Okay, counts. So I created a new environment. I copied the count. I created a memory place for the symbols, for the values. I copied the parent. Then I iterated through the environment. So what's this? I allocated how many characters they are in the symbols plus 1. I set it like this. Wait. Copy, then I copied this. Fine. This is okay. Copy is also okay. Now defining a variable. What? Elval. No. Def. So how can we define a variable? We can define it in the local environment, or we could define it in global environment. So wait. Now variables can be defined in local or global environment. So this is some method that will define the global environment. This works by simply following the parent chain up before using len put to define locally. Okay. I get this method as well. Basically, if we define it in an where's my pen? If we define it, if we use the def keyword and we define it here, it will travel all the way up to be defined. It depends on the key that we used. So what do we have then? We have a couple of built-ins. Okay. And now built-in dev, where is it? It's here. It's here. Next we have this built-in var method. So what is the built-in var doing? So it has some assertions. It does what here? It creates symbols, counts, non-symbol provided. String compare 0. This one 0 as well. Then I create an S expression. So now this is the calling method. So I think I couldn't find the issue here. The code seems okay, or does it? Wait. What is the best way to debug segmentation errors? So the call, I think the call is also okay. I think the call is also okay. Total f formals count. Well, there's a count here. If the count is equal to 0, return an error. Where did it fail? Segmentation fault. What's this? How do I read this? Wait, maybe use wall grind. Wall grind. Leak. Check. Full. Functions. 3 errors for 3 contexts. How? Have I broken something? How can I read this? Now the point is, how can I read this? I don't know how to read this. Reallocate with size 0. 476. Oh my god. Eight. This reallocate didn't work. Main elbow evil, elbow evil, elbow evil. 507. I don't think this is it. Oops, 263. So 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 the body should be okay. The environment maybe. Where are you? There's no way this is it. There's no way this is it. I do what? What have I done? So what is he doing now? So I'm calling reallocate here with size 0. Here. This should be alright. This shouldn't be problematic. What the fuck is this? What the hell? Album pop is called by built-in lambda. Where here? Is my assertion wrong? Is my assertion wrong? Oh hell. What's the name? Flatland. Where? Ah, run? No. Oh shit, can you see it? No, you can't. Maybe I'll move the tablet away for now. So I'm here now. I'm here. Print a count. It's 2. Next, print a count. It's 1. Next, print a count 0. Print formals. Print formals count. Print formals. Is it cell 0 should be only two, yeah. Cell 0 symbol, it's X. Cell 1 should be Y. Print body count, it's 3. 1, 2, and this is the third guy. Print body cell 0. No, not type symbol, it's a plus. 1 is an X. And 2, it's 4, so it's an S expression, right? 0, 1, 2, 3, 4, it's an X expression. So why is this happening? Next, no. Can I break exit? Yeah. One 197. Okay, print GTB functions break 197 run. Why is this happening? It's here. Print v type, print, it's an S expression, print v count, print v cell 0 type, it's a symbol, right? No, it's a Q expression. Print v cell 0 count, b type v count, so 0 type, it's a symbol, right? Sim, it's an X, and 1 it's a Y. So what's the type of 1 here? It's an S expression. 0 count 3. Wait, the only thing now I need to do is change this, and this is 0, so this will be the type, it's this, so it's a symbol, it's a plus, it's an X, and 2 is not 2, is a type, it's a Q expression. No, it's an S expression, so it should work. How do I skip then? How to skip in GDB? So it's finish. Where am I now? At the same time, print F type. What is this broken? Where? 4, 9, 7. Print V type. So if I do next, print F type, print F type. I have no idea. I have no idea. Oh God. No fucking clue. Hmm? It's here. So if I do finish, oops, print v, print e, print v count, print v. What's the simplest definition I can think of? Is this one, right? Let's break down the wall grid. How, 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 how. L will pop at line 198. You need to ensure that the reallocate is not called with a size of 0. 198. Oops, no, I don't want this. So, break 197. Oops, no. Run. No. This. Skip. Wait, I messed up. Well, the GDB functions. Break 197. Run. Continue. Okay. Continue. Continue. Continue is the fourth one. It's the fourth one. Let's do this again. Let's do this again. Break 197. Run. Continue. 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 It's here. Print v count 2. Print. Wait. 197. 2. Print I. X type. Print X. So it's not simple. What's type 3, 0, 1, 2, 3? It's a function. Print X. Body. Print X built-in. Is it a built-in one? Ah. must be fucking kidding me. You must be fucking kidding me. You must be fucking kidding me. If this now works, then son. I don't think it will, but if it works. The worst thing is I have no idea what happened. You know, like these, I mean, let's not jump ahead. Let's see. It works. It works. It works. It works. I'm gonna jump from the fucking balcony. It works. So it's not even. It's not even. Oh god. I mean, first of all, tech GDP. Thank you so much. But this is not even intuitive. How the hell? Wait, where is the stack trace? I think I copied. Yeah, I copied it here. So this is the whole stack trace. Two seven six. So, oh man. So why was this happening? Let me think about it. I was trying to copy an error. There was no space because here I created the size of an error, but I had no errors. So what was happening here? Let me take a look at this again. Where are you? You are here. I'm evaluating this expression. But what was failing? Well, seems like I'll never know. Invalid resize of 1. Fuck it. At least I'm happy that I did this. At least I'm really happy that I did this. So, thank you. I'm gonna stop my stream here. I'm gonna go grab a beer and celebrate in peace and tranquility. Thank you all for watching and see you in the next one. Bye bye.